We are continuing the problem we started in the last video. Just a reminder, we checked our critical points. On the boundary, we came up with this system of equations. We looked at case 1 and 2 already. If x is 0, I wouldn't be able to divide by x to solve for lambda. If y was 0, I wouldn't be able to divide by y to solve for lambda. Those are the two things that could go wrong. Turned out that neither one of those gave us any new points. We actually determined that case 2 didn't give us any points. Case 1, actually I believe the points 0, 1 and 0, negative 1 would make this equation true if lambda is equal to 0. Lambda, of course, will be 0 anytime we have a critical point. Okay, but those points we're already going to be checking because they're already critical points. Okay, so we're ready to look at case 3. X isn't 0 and y isn't 0. So from equation 1, I can now solve for lambda. So lambda is 2xy over 2x, which is just y. Equation 2, I can solve for lambda. So lambda is x squared divided by 2y. Now, I'm going to use that information together to make the brilliant observation that lambda is equal to itself. So this characterization of lambda has to equal that characterization of lambda. And that's going to tell me that x squared is 2y squared, because I can multiply by the 2y to get it out of the denominator. Excellent. So that gives me a beautiful relationship between x and y. Let's see, I'm going to just erase the work that got me there. Okay. So x squared is 2y squared. That means x is plus or minus the square root of 2 times y, because I can take plus or minus the square root of both sides. Do be careful as you're looking at the signs of things. If x squared is a multiple of y squared, they could be the same sign or the opposite sign. Sometimes you're going to get a relationship that x is a multiple of y, and then they have to be either the same sign or the opposite sign, depending on whether that number is positive or negative. Okay, excellent. Now, with this relationship, what I haven't used yet is the third equation, which is the constraint. So that was x squared plus y squared equals 1. But now x squared is the same as 2y squared. So 2y squared plus y squared equals 1. 3y squared equals 1. Y squared is 1/3. Y is plus or minus the square root of 1/3. Okay. And that's going to mean that x is plus or minus the square root of 2 times the square root of 1/3. Two plus or minuses are just going to leave me with two options. I either get a positive or a negative. That's plus or minus the square root of 2/3. And here, because my relationship allowed for them to be either the same sign or the opposite sign, I sort of get to mix and match the signs. So I'm actually going to get 4 points. X could be positive root 2/3, and y could be positive root 1/3. X could be positive root 2/3, and y could be negative root 1/3. X could be negative root 2/3, and y could be positive root 1/3. Or x could be negative root 2/3 and y could be negative root 1/3. Okay. I'm just going to call those points A, B, C, and D. Okay. And now if we plug into f, I've erased my formula, but f of xy was x squared times y. X squared, of course, is just going to be 2/3, and then I'm multiplying that by y. So here I'm going to get 2/3 root 1/3. When y is negative, I'll get negative 2/3 root 1/3. When y is positive, I get 2/3 root 1/3. And when y is negative, I get negative 2/3 root 1/3. So I can see the values that I have here. I've got one positive number, one negative number, and 0. That makes it very easy for me to see what the biggest number is. It's the positive one. So that's my max and my min is the negative. But of course, the way I phrase the question is I always ask for the location and the value. Okay, so f has a max of 2/3 root 1/3. And certainly if you wanted to rationalize that, you can, but these problems are long enough that I'm not going to require that. Okay, it occurs actually at two different locations. So the value is unique, but the location is not. It occurs at the points that I've labeled A and C. And perfectly acceptable to label your points so that you don't have to copy out the coordinates again, because that does get fairly tedious. Okay, f has a min of negative 2/3 root 1/3, and it occurs at points B and D. Excellent.